video is brought to you by Vita Bee Health. Thanks Vita for sponsoring this channel. Please check them out, link in the description of this video. Hello everyone! In today's episode, I had the pleasure to speak with Shannon, PhD student at Ohio State University and an expert in pesticides and adjuvants. Dr. Shannon's work has been crucial in understanding the impact of these chemicals on the health of honeybees. His most recent work is a review article about adjuvants and their effects, which you can find in the description of this video. If you're listening on Spotify, you can also find it in the notes of the podcast episode. In this interview, recorded live with members of my academy, we discuss the pros and cons of pesticides and adjuvants combinations, the surprising ways researchers and farmers are using this knowledge to mitigate negative impacts on honeybees, and other topics. And now, I present to you Dr. Shannon.
Hello everyone, welcome everybody. I believe we have some people of the academy here. Today I have the pleasure to have Shannon with us to discuss one of his publications that got my attention, and I'm a big fan of this kind of subject, and apparently I'm the only person on the internet that talks about pesticides. And I want to continue this trend moving forward in 2024 because I think it's something that needs to be said. And Brendan did a fantastic job in his review article discussing the pros and cons of adjuvants and pesticide combinations to the health of honeybees, and it is with great pleasure that I have Brendan here today to teach us a little bit more about this subject, something that I'm interested. I know a lot of people out there are interested in that, and we have the man here. Brendan, how are you?
Doing good. Thanks so much for having me join today.
Brendan, it's a pleasure to have you here, and I want to have this conversation for a while, and we're trying to schedule, busy guy. I'm also busy in other things, but we finally make it happen. So I want to start first asking, it's a tradition here to ask how you get into bees and the things that you're working right now.
Yeah, so I originally got into beekeeping in my undergraduate degree at the University of Central Florida. I actually studied chemistry, and so I really had nothing to do with bees, and I joined a Facebook group from the university called UCF Wannabes, and someone posted in the group and said they're going to do a hive inspection, and it's open for anyone, no matter what your experience level is. So I showed up, and it turned out that the person who posted that was the beekeeping class professor, and so I went beekeeping with him over the summer, and I just fell in love with it, and I came back every 2 weeks with him, eventually became the teaching assistant for his class, and then I took about 3 years away from beekeeping while I got a job, paid off some student loans, and realized how much I missed it. And so that's when I reached out to my advisor now, Reed Johnson, to join his lab. And he accepted me into his lab, and I started as a master's student, studying the effects of adjuvants on honeybees. And now I've continued with him for my PhD.
So you are a PhD candidate right now?
I'm a few months away from being a PhD candidate. I'm a pre-candidate, candidacy student. Yeah.
So you're probably finishing 2025?
2025, May 2025 is the goal.
All right. So yeah, all the luck, man. I think you are in a fantastic hands. Reed Johnson is one of the smartest person I know. I met Reed a long time ago. Independently working with two different projects, we start to see similar patterns, and then Jay Evans at the USDA in Beltsville put us together, and that's the way I met Reed for the first time. And fantastic guy. You couldn't choose a better person.
Yeah, he's really great. He's one of the few people that really have the expertise with both honeybees and pesticides. I feel like those two often clash and don't really interact very well, but he has a lot of knowledge about both, so he's been really great to work with.
Yeah, and a brain that is impressive. His capacity to put things together, that's something that I like about Reed, is his capacity to put a lot of things together and synthesize in a very easy to digest way. I learn a lot from him.
Mm-hmm.
So let's start with this. So you wrote a review in a journal of insecticides about the risks of spray adjuvants to honeybees. And I want to start this conversation by asking you, what is an adjuvant?
Yeah, so that's usually the first thing I have to address when I give a talk. Whenever I present to beekeepers, I make them say the word adjuvant because people even have trouble pronouncing it because it's such a weird word. But what adjuvants are is they are products that are added to these tank mixtures of pesticides. So pesticides aren't always applied, one insecticide by itself. It's often an insecticide plus a fungicide, and often adjuvants are added into this mixture, and what they aim to do is really to improve the pesticide mixture, and they can do this in a lot of ways, including reducing drift so that the spray of a pesticide does not affect neighboring crops. They can act as emulsifiers so that the mixture doesn't kind of clog up, and it stays like nice and smooth flowing, so it sprays well. They can affect the droplet size, but their primary purpose is to act as surfactants, penetrants, and spreaders onto leaf surfaces. And so when a water droplet falls onto the waxy surface of a leaf, it will like bead up and form like this bead of water. But when an adjuvant is added, that bead of water will flatten out a lot more, and it will allow the water and the pesticide to penetrate through the waxy cuticle of the leaf and have the effect on the plant and on the targeted pest to make the pesticide more effective.
So it is supposed to help, right? And to minimize the exposure of the main component of the pesticide. So the main idea of an adjuvant is to be a helper, to spread the main component of the pesticide, to use the minimal pesticide possible. So it is a great idea, right?
Right. And it's really funny because the goal of these, like you said, is to make the pesticide work better so that we can use less pesticide. But then it's kind of like an issue now because a lot of research, including our research, has shown that these are actually toxic to bees. And so these aren't really helping the environmental safety like it was thought that they would.
We're gonna get there, but I wanna follow a very structured rationale here for people at home to really follow what we're gonna talk later on. So we have an adjuvant. They add is supposed to help to minimize the amount of pesticides, but they got these adjuvants from different lists. And so what is an inert ingredient? So normally they consider adjuvants to be inert ingredients.
Mm-hmm.
And because they claims that they don't do anything. So what is an inert ingredient? And let's start discussing after you said that the problem of regulating these compounds and what's the problem that we have here.
Yeah, so adjuvants are not just made up of one thing typically. Often it's multiple what's called principal functioning agents that make up these adjuvants. Now the term principal functioning agent is kind of analogous to active ingredient in pesticides. The only reason they're not called active ingredients is because they don't claim any pesticidal properties. And so these principal functioning agents are individual compounds that are on the list of inert ingredients that the EPA has. The EPA has their own list of inert ingredients, and what these are is they don't require the same rigorous testing that a pesticide active ingredient would have to go through. And so pesticide active ingredients, when they get registered, they have to go through a lot of environmental testing, including 5 stages of honeybee testing to prove that they're safe for use. But these inert ingredients have almost no environmental testing needed. They will sometimes do modeling based on the chemical structure, but the actual lab testing is usually very minimal for these products. And so because adjuvants aren't ever mixed in with the pesticide until they're added to the tank mix, testing with these products is not done prior to their use.
I see. So they are considered to be safe, but they're never really tested in more rigorous ways here by the EPA to see if kills honeybees. Most of the information they have about those products is based on other research from other areas, other industries, etc.
Mm-hmm.
So, why this is a problem?
Yeah, so I mean, it's an issue because these products are considered inert because of historical testing that had been done previously with them, but they're never applied. This testing is often done on its own with the inert ingredient, but they're never applied on their own. Adjuvants are always mixed in with pesticides, and research from our lab and others has shown that adjuvants mixed with pesticides are more toxic than adjuvants alone in a lot of cases. And additionally, adjuvants can be toxic on their own to honeybees, which you wouldn't expect them to be as inert ingredients. But they're showing toxicity, both lethal toxicity and sublethal toxicity to honeybees, and likely to other beneficial insects as well.
So, since you already start talking about the toxicity, what do you guys found over there? So how those adjuvants are killing bees? So for the beekeepers at home to be aware of that a lot of the problems that we discuss, especially when I visit many beekeepers all over the year, we have that all those stories, start to become a pattern. And in my mind, I cannot say as a scientist that I know what it is, but as a beekeeper, I kind of know what it is. Mm-hmm. It's just there. It's just people cannot see it because they don't have the knowledge. I think we have a big pesticide problem all over the country that need to be addressed. So how those adjuvants and those combinations, based on the results you got and the literature that you screen, are killing bees?
Yeah, so the actual how is really up for debate. No one is really sure how these are killing bees. That's one of the goals of my PhD research, is to kind of uncover a little bit of the mechanism of how these are working. It's thought that they act like insecticidal soaps do, which interestingly, insecticidal soaps have been used for over 100 years, but people still are not 100% sure with how they work. But it's thought that they kill insects through either drowning through the spiracles. So honeybees don't have a nose to breathe like you and I do. They have these little holes on the side of their body called spiracles that allows the flow of oxygen and release of CO2. And so the thought is that they are drowning because the adjuvant breaks the surface tension of the water so that water enters into the spiracles and causes them to drown. One of the other mechanisms that's proposed is a cuticular mechanism. So like leaves, honeybees and other insects have a waxy cuticle on their outside. And what this does is it keeps the water inside of the animal and keeps the water from evaporating so that they stay hydrated. And it's thought that the adjuvants could be breaking down the waxy cuticle of the insect and then therefore reducing the ability of the insect to keep its water content and also keep things like pathogens and toxins out as well. And then the third potential mechanism is at a cellular level. So animal cells have or all cells have a phospholipid cell membrane bilayer. And so this acts to keep the good things in and keep the bad things out. It mediates the transportation of water and chemicals across the cell membranes, and the adjuvants are thought to disrupt this bilayer so that it kind of leaks, and the things you want inside kind of get out, and the things you want outside get in, and leads to the death of the cell in that way. And so those are the three proposed mechanisms that we've talked about and that others have talked about in their research that we covered in this paper. As for the effects, those are a little easier to see. I mean, you spray bees with adjuvants and they die. At least that's what our lab has shown. And so
clear. So in your face,
Yeah, and so that is pretty clear. But the toxicity of adjuvants is not equal for every product, but in our lab we used a Potter spray tower, and so that acts to spray a product in like a fine mist onto a group of bees, similar to the way bees would be exposed to pesticide in the field if they were out foraging on flowers and were directly sprayed. And so we did this with 12 different adjuvant products, and we've also tested a bunch of individual components, the principal functioning agents as well. And we see that we test for acute mortality, which is 48 hours after they're sprayed, how many bees are dying. Other labs have shown other things. We've not tested sublethal effects in our labs, but other researchers have shown effects on bee larvae, and that these can be toxic to bees in the larval stage in the brood. They've also shown that it can affect honeybee learning. So honeybee learning is measured often through proboscis extension reflex, and so bees will expose bees to a smell and then give them some sugar, and so then when they expose the bees to the smell again, the bees will extend their proboscis to try to drink the sugar again. And if their learning is impaired by something like an adjuvant or another toxin, they won't extend their proboscis as readily as a bee whose learning hasn't been impaired. And so they've shown that learning can be impaired through this proboscis extension reflex. And also, which I find really interesting, it can increase the transmission of pathogens between bees, which we as beekeepers know that pathogens are one of the leading causes of colony failure through the spread of varroa and other things like that. And if if a pesticide from the outside is coming in and affecting the transmission of pathogens within your colony, it could cause the decline of a colony to be even more rapid.
You mentioned transmission. You mentioned that those components might messing up the immune system and that create more pathogen, and that's the way you spread more, or you're mentioning something direct with the transmission itself?
I think it's more it's the transmission itself, less than creating more. It's Julia Fine 2017 paper,
which is coming as a video soon.
Okay, great. Yeah, she's really great to talk to about this as well. So, but yeah, she'll tell you more about it. But the summary of the paper was that these, especially organosilicone adjuvants that they were focused on, can increase the kind of one bee passing on to another the different pathogen.
I'll take a look at that paper. I saw it was something related with the transition, but the first thing that comes to my mind was more production and therefore transmit more, but I'll take a look on that. Mm-hmm. So we talk about adjuvant itself, but it's something that is probably the biggest concern that I have is those interactions, synergistic interactions. And can you tell us what you know about that? Because when I visit beekeepers, which is I do every year, lots of visits and talk with them and trying to understand the rationale for what they are doing, they like to do their tests, and I encourage them to do their tests. But sometimes the tests are, let's put this together and see what happens, without any previous knowledge or any kind of previous understanding of basic chemistry. Can you explain to us what the synergistic effect is and the examples that we have that you revised on your publication so nicely?
Yeah, so synergism, what synergism is two compounds that each have their own toxicities coming together and having a toxicity that is greater than the additive toxicity between the two of them. And so oftentimes this would have to be 5 or 10 times greater to be considered synergistic. Now, things can also be antagonistic. And so you have two compounds, each with their own toxicities, and they come together, and the additive or the toxicity of the two of them is less than the additive toxicity of the individual components. And so we see that some adjuvants show synergism and some adjuvants show antagonism. And in our paper, we showed that that this is more adjuvant dependent than it is pesticide dependent. And so we think that it's the adjuvants and not the pesticides that are driving the toxicity in these tank mixtures. And so the interaction, whether it's interacting in before it enters the bee or after it enters the bee, it is not really sure. We're not really sure yet. There's kind of three ways that things can interact. They can either interact before affecting the organism to create a more toxic compound. They can interact by increasing the kind of like the penetration or increasing the entrance of the product into either inside the organism or inside the cells where it would take action, or it can stop the I don't know, the metabolism or breakdown of the product. And so a lot of people talk about P450 mechanisms and things like that. And that's where we see a lot of the synergism. So P450 enzymes are enzymes that break down toxins, specifically organic toxins in a lot of cases.
When I look in the literature, I saw a lot of combinations, especially with fungicides happening. Fungicides, for some reason, combined with pesticides and adjuvants, you can see a lot of synergistic effects. Like, it's not a small ones, you know. Normally it's 1 and 1 and 2, and then to consider to be synergistic, 1 and 2 become 10. I'm talking about thousands,
right?
You know, thousands. Like a 1 in a billion dilution can kill a whole hive. And it's very scary to me to think about this, because it's that kind of event that happen and disappear. There is no way to trace. There is no way to go after. The beekeeper going to have a huge loss. Nothing's going to happen to whoever did that, whoever put this in the environment without any consequences. And I hate, you know, when I talk with farmers, I have this, I'm very keen to low government, but the only time that I agree that the government should intervene in some of these things is when these pesticide companies start to dump things completely irresponsible in nature and water without any consideration. That's, I think, is the only thing that I feel like we need to do something. The only way to do something is through government intervention or some sort of blockage, because these guys don't give a dime.
Mm-hmm.
So in your research, I saw that you wrote this paper, which is a summary of what we have today. It's a kind of the know-how now, where we are in our knowledge about adjuvants. And you also wrote some recommendations. So what are those recommendations? How do you feel that we can move forward and minimize the impact of those pesticides, of the adjuvants in general?
Yeah, so there's a few different stakeholders or groups that can affect the exposure and risk that bees are facing from adjuvants. And I think the most important one is the pesticide applicators. I think that bees and pesticide applicators often butt heads a lot because bees are like, you know, or beekeepers are like, you know, you killed my bees, and pesticide applicators are like, no, I didn't. But I think we really need to work together a little better and communicate with each other on, you know, how we can solve this in a way that's mutually beneficial for both parties. And so our recommendations for pesticide applicators is to not use adjuvants in spray applications unless they're specifically recommended on the pesticide label. So some pesticides say this product needs an adjuvant if you're using it on, you know, a waxy leaf plant. And so in that case, an adjuvant is necessary and should be used. But in all other cases, we think that it should not be used. Some pesticide applicators may still want to use adjuvants because they often act as an insurance policy to make sure that their product is effective or to reduce drift. And so our next recommendation is if adjuvants are being used, use it at the minimum application rate. And so adjuvants on their label have a recommended rate of application. It'll say something like add 16 to 64 fluid ounces per 100 gallons of pesticide application. And so oftentimes pesticide applicators will see this and add closer to the 64 end of the range, the higher end of the range, when really the lower end of the range is almost as pretty much just as effective, because adjuvants kind of have this like plateau of effectiveness. And so if you're using it at the low end of the range, not only is the pesticide applicator saving money, they're also reducing their risk to honeybees. And then thirdly, it's typically best management practice to apply pesticides in the evening when bees aren't active, so that the exposure that they do receive is kind of a residual exposure and not a direct exposure to a spray. And then lastly, which is kind of a difficult point to get across, because in 2021, there were 206 adjuvant products that were used in almonds in California during bloom while bees were active, which is kind of the focus of a lot of our research, because that is really the primary place that bees are being exposed to adjuvants. And we've tested 12 of these products. And so this is a little bit harder to say, but for pesticide applicators that are still using adjuvants, to avoid using the products that we showed in our research to be toxic to honeybees. And the reason I say this is because the number 2 product that was used was the product called Dynamic, which we've shown in our research to be one of the most toxic adjuvants to honeybees, and others have also shown this product to be toxic to honeybees, but it's still the number 2 most used adjuvant in almonds in California. It affects like thousands of colonies every year. So
yeah, I as a consultant, I advise, and I have I'm in a privileged position to see some beekeeping operations from inside, even from the financial point. Mm-hmm. And from my experience, there is a lot of people that are very successful, and they're getting rid of the pollination services exposure, or are adding in their business model a system that they just put the bees there, get the return of investment of a pollination, and sell the bees there. Because when they bring those bees back, how people in America like to say, shit happens. Mm-hmm. So they have big losses when they're getting rid of the potential exposure to these pesticides and pollination in general, not only pesticides, but also all the pests and diseases from the pollination services. They're avoiding bring those bees back. They said their bees things are much better. The things are much more stable for them, and they make a little bit less money, but it's the stability allows them to use the money to invest in a different portfolios and things like that. So it's something to consider. Where is cutoff? What's the benefit to be? I don't know. This whole show is about helping the beekeepers. So I'm always trying to find ways to bring information and sometimes help them to develop a different business model that they can avoid where the problems are, and people that doesn't have a way or a solution to avoid those paths, they don't have a choice. They have to do it. But for those that have, I think there is another recommendation is to avoid as much as they can, because shit happens.
Yeah, I mean, that's one of the problems with pesticides, is it's something as a beekeeper that's so out of your control.
Yep.
Your beekeepers will forage in this 3-mile or 5-kilometer range around the hive. Unless you have this huge plot of land, you're not going to be able to control everybody's pesticide usage. And so our recommendation with beekeepers is to just communicate with your neighbors. Maybe they won't change how they apply pesticides, but maybe they'll tell you ahead of time, and you can cover your colonies, the day before. the day before they apply pesticides, and maybe you can mitigate the risk at least a little bit to your bees. It's always difficult to get groups with differing goals to cooperate together.
That's complicated. Well, one of the things that I see, you're right. This is the thing that beekeepers have no control about, especially the neighbors and things like that. But there is another level of that. I don't know if you're aware of that. Is that it is very hard to not find pesticide incorporated in water and in soil. Almost 3 inches in, you can find huge quantities of, depending on the crops you have around you. These things spread and stay there, and bees collect things, the plants absorb things, and there is no place on the planet anymore that we are safe from these chemicals everywhere. It's something that bothers me because right now in this conversation, we're just touching one level of this, which is honeybees, one species that is important to us. But there is a whole level of complexity of these chemicals, what this chemical does everywhere, and the potential combinations that we can get from the human level, from the animal farm level. So with that in mind, I want to ask you, since you're a young researcher and is going to go to the market, and I want to ask you something, or at least to keep you in mind. Do you know anybody that are at least thinking for other solutions to get away from chemicals? Because sometimes I feel like I go everywhere, everybody's trying something different, but it's a new chemical. There is right. Is anybody thinking about solutions that is not chemical related?
Yeah, I'm glad you asked that, because it's actually we share a lab space with one of the leading integrated pest management labs at Ohio State. And integrated pest management is basically taking multiple levels of managing pests, starting with kind of cultural and mechanical controls. So this can be things like in almond production, shaking the kind of nests for the navel orangeworm off of the tree, so that they can't overwinter very well. But can also be things like a sticky board. Could be a good mechanical control to stop flies and things like that can affect pests. And then the next level up, you want to implement biological controls, so things like lady beetles or ant lions, things that eat the bad insects to benefit your plants. And then kind of at the top of this pyramid is pesticides. And really the goal is for the mechanical control and biological control to be good enough that pesticides aren't needed. But sometimes, pesticides are needed because a farmer is not going to want to lose their crop. And so it's important that pesticides are not used without necessity. It's important that things like scouting and kind of determining if your plants really need these products and what levels they need these products at. And then also the choice of pesticide product that's being used. Oftentimes the synthetic chemical is jumped to first because it is the most effective, but it also may be the most environmentally harmful. And so it may be better to use a environmentally safer, a more natural pesticide product that potentially has lower toxicity to honeybees before the synthetic chemical is immediately used. And even beekeepers are guilty of this. I mean, there's beekeepers guilty of using amitraz every year. And now we see amitraz resistance in our honeybees so bad that beekeepers have to use off-label products. And so I think beekeepers, because beekeepers are farmers, they farm bees. Beekeepers are just as guilty of this as as farmers are in a lot of cases. And yeah, I think it's just important to kind of look at it in a holistic perspective and see what other than pesticides can I set. And the problem with beekeeping is there's not a lot of options for integrated pest management controls. For example, there's no biological control for varroa mites.
The main. Let me elaborate here because I think I'm old and I can't say that regarding the bees, and I'm in contact with beekeepers that are much older than me, and the stories are very similar. I think what we lost in the last 50 years in beekeeping is that we lack the main weapon of honeybees that was used before. Beekeepers used to breed out all the problems. Okay, we have a new problem. We have the ways for the bees to breed things out, and they go in that direction, and they breed almost for everything. The only thing they didn't breed so far was varroa.
Mm-hmm.
Maybe it's because of the system, but also I have to.
They even are breeding up for varroa in some cases with varroa sensitive hygiene. I mean, those are really great programs going on as well.
I'll get there. Yes, it's pretty slow, but I feel that it's much more complicated to breed things, to use breeding, which is the most powerful things that we have with the honeybees today. First, very few people are thinking about breeding in the old-fashioned way. Third, I think we have a problem, and I think it's related with pesticides. Because pesticides interfere with almost every single level of the honeybee physiology, immune system, everything. And we have a combination of them. If you put the list of all the pesticides they encounter, it's almost 200. It is impossible to breed a bee that is immune to everything. This is something that we didn't have in the past too much. So that breeding was still an option. Even the breeders today still having problems to breed to things because the breeding is not even, okay, now we have a bee, we solve the problem. They never solve a problem because there is no way to breed anymore with all these components. And I really think it's related with pesticide use. But I'm not doing research on that. It's going to be just me as a researcher, just words in the air. But if I have to guess, I put all my money on that.
And like you said, I mean, all of the stressors for bees interact with one another. A bee colony affected by pesticides is going to be less able to deal with a problem like varroa or pathogens than
everything. Collecting memory, they lose everything.
Right.
It's just and apparently this is not a big deal. It's something that we needed pesticides. I don't buy that crap. I'll never buy that crap. We are human beings. If we put our mind to the right direction, we find the right solution. So when people come to me and say, no, pesticide is a necessary thing, bullshit. I'm sorry. Sorry about my wording, but I crossed the line already with the pesticide people. And there is a campaign of fear. I've been in those meetings with farmers, and those pesticide company people are there, offering these fancy meals to the farmers and the beekeepers and all this. And it just created that sense of fear. Oh, if you don't buy my thing, you're going to lose. You're going to lose all your crop, and, just listening to that, oh, my God, there is active money in it to create this fear. Sometimes the farmer doesn't need the pesticides, like you said, with pest management, with best practices, and they just buy for fear. And I'm done with that. I can't handle this anymore quietly. I need to talk about this. Sorry to put you in the middle of this. So how do you feel about that? Do you have thoughts, or you're going to be stuck in that line of research? Is job security for you, or you have thoughts that you may, find solutions, real solution? Can you hear me?
No, I lost my microphone for a minute. I'm trying to.
I can hear you now.
Can you hear me?
Yes.
Okay. Can you hear me now?
Yes, I can hear you. But apparently you were not hearing me.
I hear you now.
Okay. I was just.
But no, I totally agree. It's
Can we focus to solve problems instead of, because to me, pesticides is a good business model for only one people, to whoever produces. It's not good for farmers. It's not.
Yeah,
They don't have the return of investment they think they have. I don't know. I don't know.
Yeah.
I don't know how into these things you are. So, but I know you're a young researcher. Just want to bring to your mind now so you can set up yourself. And
I think, like
do a
I said
better job.
before, I think pesticides should be as a last resort type thing. And getting back to adjuvants, I mean, these adjuvants are almost like unnecessary. In many cases, they're unnecessary toxins that are being added into these pesticide mixtures. And so reducing adjuvant usage, I think, is much easier than reducing pesticide usage, because a lot of times these farmers are using pesticides, even if they are using an integrated pest management approach that is trying to reduce pesticide usage. Sometimes the cultural controls and the biological controls just aren't good enough, and they feel that the pesticide is necessary in order to protect their crop. But in that case, the adjuvant still probably is not necessary. And so adding that adjuvant in or removing the adjuvant component could still decrease the risk to honeybees in some case.
Yeah, I agree with that. I just when I'm ranting like that, it's because I don't see anybody asking the right questions. How you move away from that is always like a fixing a solution and put something. It never is a cycle that never gonna end, and that's
Right.
what I'm frustrated about the research community and the funding agencies too, which is another subject completely. Who give the money is who control the researchers.
Right.
A lot of people in academia always are in the system and don't see this from the distance, to see that people are putting the money where they want, and the researchers just need to do what they do, go after those grants and try to survive.
Right.
But if you step away and look around a little bit, you're gonna see that nobody's asking the right questions and trying to put the money to find solutions that are gonna be really helpful for everybody. Because
right,
I don't want this thing in my water that I drink, or my kids' water, or my dog's water.
right.
Yeah, but I love what you're doing. I know you're doing some good research, and I don't want to touch this right now because I'm going to make a video about that later. So
okay,
stay tuned. Brandon is doing a fantastic job finding the mechanisms behind those interactions with honeybees. And I didn't touch base too much today is because I have bigger plans for the future.
Yeah, and we're also working on, like I said before, adjuvants are not all equally toxic. We found some that are pretty highly toxic to bees, and some that we couldn't kill bees even at 100% concentration. And so we're trying to use these, we call them low risk adjuvants, or they're almost, I would call them bee safe, but that's not really nothing is really safe. Right?
Yeah, be careful with the statements. That can bite your butt in the future.
Yeah, right. So we call them low risk adjuvants, and we are adding them to forms of varroa control, different active ingredients, primarily the non-synthetic active ingredients, to improve the efficacy of more natural active ingredients in bee colonies. that have been historically not as effective as the synthetic compounds, in order to reduce the usage of synthetic compounds within beehives to control varroa. And so this has been pretty successful so far. And right now we've got a provisionary patent on our formulation that we are trying to work with. We're working with a few different companies that make products, pesticides for varroa control.
Is it published, the patent already?
The patent isn't. It's a provisional patent, so it's not published yet. We are working on the paper right now for it. It should be published by this summer.
But the patent is available. Oh, okay. I will find that out.
Yeah. So,
cool.
So that's what we're working on next with adjuvants. But we're still continuing the toxicity of the more high risk adjuvants, as well as trying to work with pesticide applicators, especially those in California during almond bloom that are applying pesticides, to do a risk communication strategy, because we've been publishing data. Data's been published for over 10 years now on the toxicity of adjuvants, but we still see adjuvants used in almonds. Over 60% of almonds have adjuvants applied to them. And this is a huge effect on bees and beekeepers. And so we're trying to find where the disconnect is for pesticide applicators, because bees are needed for almonds, yet these products that are toxic to bees are applied on almonds. And so if you want bees there to improve your product, why are you applying products that are toxic? Because then their actions are not really aligning with their goals. And so there seems to be some kind of misperception there on adjuvant toxicity for bees. And so we aim to target that misperception and kind of fill those knowledge gaps so that the decisions that pesticide applicators make more align with their goals, which should be to have bees present in almonds to improve their yield, and which would also improve safety for bees and productivity for beekeepers.
Yeah, you just summarized very well what your lab does for the last 15 years. Reed is doing a fantastic job finding out what's the best combinations here and there, and helping the pollination crew there to apply the right mixtures that cause the less damage to honeybees. And he's been very successful. If you see the charts, from the last 15 years, a lot of things have changed because of what you guys are doing there, and I think something that you guys need to be proud of. Because of you guys, a lot less bees have died, that's for sure. And a lot of combinations were avoided, and much less pesticides were exposed to nature, and that's very important. And I want to congratulate you on that.
Yeah, thank you.
You and Reed and all the people in your lab there, congratulations for the good work. So with that in mind, I think I'm going to open the floor here for if some of my academy members, if they're still there, have any questions. Don't be shy. Now is the time. Mary, Andrew, Kyle, if you're still there, if you have some questions, please publish the question in the comment section, and I'll show the question to Brandon here. So let's give them some time to see if they are still shy. Brandon, let me ask you, while they are writing down some question, if they will, what there is any other projects you're working on right now that is, I saw some of the publications, things that are not published. Anything that you can share with us?
Yeah, I shared most of it already of what my PhD project will be. We're also working with, or I'm working with a couple of others in our lab. One student is really interested, Lily Johnson, no relation to Reed, just same last name. Now, she's working on kind of interactions between insecticides and fungicides that are applied in soybeans. Because our lab has shown that soybeans, which were thought to be a self-pollinating plant for a long time, actually are visited by honeybees. Honeybees use the nectar for soybeans, and also are likely benefited from bee visitation from soybeans. That kind of raises a lot of questions on, the labels for pesticides that are used in soybeans, where typically products have been applied in soybeans because it was thought that bees are not present. And so the bee hazard requirements were not really listed on the label. And so we're doing or bee hazard requirements that were listed on the label weren't really followed because it was thought that bees weren't there because the farmers looked out and didn't see any bees. But the bees are there. So Lily is doing a lot of research on this insecticide and fungicide and the interaction the two of them have together, which is a synergistic interaction. And I've done the laboratory testing on the toxicity for it, and then she has done the bulk of the testing, which is mostly field testing, to see if it affects visitation rates to soybean flowers. So,
cool. I'll be delighted to talk with everybody in the lab. Actually, you guys, all of you are doing a great job.
Yeah.
I have a question here from Andrew. Let me put on the screen. Have you looked at any other crops other than almonds?
So the reason we've kind of focused on almonds is because California has this great thing called the California Pesticide Information Portal. And what this does is they collect all of the pesticide, including insecticide, fungicide, and adjuvant use in California. And so we can look at the usage rates for insecticides, fungicides, and adjuvants, and kind of see what are the top products that need to be targeted, what are the top interactions that need to be targeted. And so that's kind of why we focused on California, because the data is present there. I can't say with 100% certainty that someplace like Ohio, where I research, or Florida, where I'm from, uses these same products, although it is highly likely that these adjuvants are used in other places as well. And this is really a nationwide
concern,
applied research program. But California is what we talk about because they say this is what's used in California, and so we can specifically say this affects this many acres, like this product that's toxic affects this many acres of almonds every year. When in for soybeans in Ohio, the products are not made publicly available. The products used are not publicly available, like public knowledge. And the amount they're used is not public knowledge either. And so it's a lot harder to kind of relate the research to fields.
I see. Yeah. You have the information there. So another question for you. Are the inert listed in the label? How the label work with that on that?
Yeah, so that's a great question. Because yes and no. In pesticides, typically no, because in pesticides they list the active ingredient, the common name and the chemical name. They'll list the percentage of it, and then often they'll say other or inert ingredients and the percentage of other inert ingredients, and they very rarely, if ever, list the inert ingredients that are present. On adjuvants, because there's no active ingredient, I'm not really sure if they're required to list anything on there, but I think they're required to list what they consider the principal functioning agent, but the exact composition of that is not as specific as a pesticide active ingredient is. So like when a pesticide active ingredient is listed, they'll say, this is the active ingredient. It's, imidacloprid, and we know what that chemical is. But for an adjuvant, they'll say, oh, the active ingredient is alcohol ethoxylates. Well, there are a million alcohol ethoxylates, and we've tested a lot of them, but they can have very varying, properties based on the exact chemical from the alcohol ethoxylate group that is there. And so so yes, sometimes they're kind of listed, but it's not very specific. And so you can look at the label and still have no idea what the toxicity is. And often they don't list the proportion as well. So they'll say, it's 90% principal functioning agents, and then they'll say, it's a organosilicone, it's a alcohol ethoxylate, and it's a crop oil concentrate. And so is that 90%, is that 89% organosilicone? And then 1% the others? Because it's not clear on the label what the proportion is of these products. And so that's one of the big barriers to testing adjuvant safety. And one of the things we've really struggled with, and why we've kind of tested the products themselves in a lot of the cases, because when you test the principal functioning agents, these components in adjuvants, how does it relate to the product? It's really unclear because the products aren't clear. So thank you for that question. That's a really great point.
It is a good point, because they consider those proportions a company secret, right? So they protect those proportions.
Exactly.
So they don't want to share those proportions because they probably have tested a lot and have the data for themselves, don't want people to copy. But when they don't spread those information, the researchers only can guess what they can do about it. Interesting.
Right.
Interesting. All right. One more question, and we're done for today, my friend. Andrew is asking, as detection level capabilities are improved, is there any revisiting or retesting of approved pesticides? Well, I think that's a great...
That is a great question.
You're touching base, Andrew, in a big nest of hornets.
Yeah. So, I focus more on adjuvants than actual pesticides. So I think the answer is no, but I'm not 100% sure on that. Umberto, you might have a better answer for that. I didn't think so.
Andrew, what I can tell from my experience is the following. We better make sure we put something in the market, because take something out is basically impossible. It's really hard to take it out of the market. So when I work with the EPA people, or not work directly, but I'm involved in as a listener most of the time, you can see that the system have gaps, and the people are really good to go around those gaps and get things approved without proper, and when I say proper, in my definition of proper testing, which is not the definition of their proper testing, more videos about that later this year, by the way. But it's a complicated issue, because once it's approved, to reapprove or to touch base, let's reconsider this, oh boy, it's almost impossible. All right. And Brandon, I want to thank you one more time for your time, for your great work. And you're a young researcher going to this field, and you choose a very interesting career to yourself, and you have the mindset to do really good things. So I want to thank you for that, to help the beekeepers, help the community, and everybody around us. Thank you.
Yeah, thank you so much for having me on. You do great work, and thanks so much for bringing the research that's done and extending it to the people that it most impacts.
Yeah, thank you. So, and for you guys at home, I will see you guys in the next week inside the Hive.tv, the show about bees.